Okay, so for this problem, we have f of x equals 2x squared, and we're going to use the difference quotient, f of x plus h minus f of x over h, to calculate um, the difference quotient, or in this case, the slope. So what we need to do first is we need to find f of x plus h. So we need to replace this x in the 2x squared with x plus h. So when we do that, we're going to get x plus h. Again, just trying to emphasize that's what we're plugging in. Okay. So once we have that, that's basically the hardest part is setting this up. So we have that. We have f of x plus h, which is the 2 times x plus h squared. And we have f of x, which is 2x squared. So I'm going to put that in there, replace those from the information that we just obtained. Okay. All right. Then our next step is to expand this information. And if we did it correctly, then all of our a lot of our terms are going to cancel out. So the x plus h squared, you'll see that a lot, especially if we're working with something with x squared. So I'm going to show you two ways to do that. Okay, so this is going to be my scratch work. So x plus h squared means you multiply that 2 times, right? And you can use the FOIL method or the distributive method to find that. We talked about that before. So I'm going to have x times x plus h times x plus h, right? And I distribute that x and then that h. So that gives us x squared plus xh plus xh plus h squared, which is x squared. We have two of these, so that's 2xh plus h squared. All right, so that's one method. The other method is if I have if I have any type of factor and it's just um, being squared, what you can do is you can take that first one, the x, and square it. You can take the second one there and square it, and then you multiply the two. So that would be what? xh, right? X times h is xh. Then you just double it. All right, and then it's addition, so everything is just positive, and you get the exact same answer. So again, whatever you feel comfortable doing, but since I already know this, instead of going through all these steps, I just do that little technique. All right, and then once you have that, then we can just plug it in here. So this first part, we have 2 times, and we got x squared plus 2xh plus h squared minus 2x squared divided by h. Now, if we distribute that 2, okay, we distribute that 2 to each term, then we're going to get, I'll do it over here, 2x squared plus 4xh plus 2h squared minus 2x squared divided by h. And as I mentioned, if we did this correctly, then a lot of the terms will cancel out. So the 2x squared are going to cancel. And then we have xh plus 2h squared divided by h. And what is our goal? Our goal is to eliminate h in the denominator. Okay? Which is this sucker right there, or this one right here. All right? We need to get rid of that denominator because that's what's causing us problem. Okay? So we're able to do that. All right? So we can factor out the h here. So we have equals 4, sorry, equals h times 4x plus 2h divided by h. And then this h here is going to go away, leaving us with 4x plus 2h. Okay, so now let's think about what this means. Okay, so I call this the slope generator. Remember, this whole difference quotient is just a fancy way of saying the slope. Okay, it's more, it's a lot deeper than that because you can apply it to a lot of things, but it's the slope or the average rate of change, or in this case, the instantaneous rate of change. Okay, so I call this here the slope generator. You probably will never see that in a textbook, but that's what it does. So what do I mean by that? So remember we talked about back here, uh, when we found this here, the very beginning, we had the limit as h approaches 0, right? This is a part of the formula we're missing. It's this portion here. Because in the end, what we need to do is we need to plug in that 0. So that's why that h in the denominator causes issue, is because when we replace that h with 0, we can't have a 0 in the denominator. So that's why you want to get rid of this h. That's the goal. So anyway, so that's what's missing. That's what's missing there. So if we were to go here, right? And again, I'm going to rewrite this here, the 4x plus 2h. That's what we got. Anyway, this is the answer you would put in the lab work. That will be the answer. But again, let's just focus on that a little bit so you have an understanding what that means. So the limit as h approaches 0 is 4x plus 2h. That's what we got. This whole thing here, this whole thing right here that we just did equals this. Okay? That's what it equals. So when we have this here, then we plug in our value for h. So that becomes 4x plus 2 times 0, which is 4x plus 0, which is 4x. Okay? So again, what does this mean? I call it the slope generator. We have the function f of x equals 2x squared. And we're going to learn a bunch of these graphs in 3.5 or okay, or 3.4. So 2x squared is a parabola, and it's a happy parabola because it's positive 2. So it just looks something like this. Okay, again, it's like something like that, right? This is what the parabola looks like. So if you give me any value for x, so let's say that x is equal to 3. Okay, so that's saying, okay, what is the slope? That's the question. What is the slope when x is equal to 3? So again, this is called a slope generator. So the 3, so if I mark it here, 1, 2, 3 is right there. All right. So if I draw a tangent line, right? A tangent line means it just touches it at one particular point. So at this particular point here, okay, what is my slope? What's the slope here, right? Or m. So if we use this formula, well, we know it. So m is 2 times x squared, right? So then we just plug in 2 times 3 squared. So that's going to be 3 squared times 3 squared is 9 times 2 is 18. So in this case, when x is equal to 3, the slope is 18. And that's the beauty of this difference quotient is that you give me any point on this graph, and I can tell you exactly what that slope is. So instead of picking 2 points every single time, now we have a function, we have something we can just plug in and it will, spit out information for us that we need. But anyway, so that's the behind the scenes that many college algebra students don't know. They just see this part and they're like, what the heck does that mean? All right. But that's what's happening when you get to the next step. Once you apply that limit. But anyway, but I'm just trying to inform you what's happening here so you have an idea what we're doing here. Okay, anyway, but the bottom line is the answer to this question is 4x plus 2h. Okay? Okay, so let me just backtrack what I said here. The 2x square, right? The 2x square, oops, the 2x square represents this function, right? So this graph, the parabola. So I apologize, and I used that instead of what we found. So let me erase that here. So we just found the 4x plus 2h. So that's what we need to do. And we plugged in 0 for h, which gave us 4x plus 0, which is just 4x. So I meant to use 4x instead of 2x squared. So anyway, so we plug that in there for x and we get 12. Okay. So that's what we wanted to do. Not the 2x squared, because again, the 2x squared is telling us what that graph is. But we need to use this one to figure out what the actual slope is. But before we can do that, we have to plug in 0 for h, and that will eliminate the 2 times h, and then we'll get the 4x, and then whatever value they give us, because they'll say, calculate the slopes at these points, 1, 2, 3, 5, 7, -10. So it'll be, you know, unlimited amount of slopes, and it's just easy to just find the slope generator. And so in this case, which was this, or the 4x plus 2h, and start plugging in those values. So anyway, that's what we need to do for that. So please make that correction. Okay, so here we have f of x is equal to x squared minus 5x plus 8. And so we also need f of x plus h. So that's going to give us, so anytime we see an x, we're going to replace it with x plus h. So we'll have x plus h squared minus 5 times x plus h plus 8. Okay. So then we're going to use the difference quotient, which is f of x plus h minus f of x all over h. Okay. And then we're going to replace our f of x plus h by what we just got here, and replace f of x by this information here. Okay. Again, if we do this correctly, then things will start canceling out. So we have x plus h squared minus 5 times x plus h plus 8. And we have to be careful here because it's a minus, right? This is a minus the whole function. So we have to be careful that this thing is, this part has to be, is subtracting this whole thing. So we put x squared minus 5x plus 8, right? So subtracting that whole function there, not just the x squared, but that whole function. And then this is all being divided by h. Okay. Then I just start multiplying things out. So as you notice, we see the x plus h square again. Again, anytime we have a square, we go through that, multiply the two factors or use the FOIL method or distributive method, or you can just do the little trick where again, you square the front, you square the back, you multiply the two, and then double it. So x times h is xh, then double it, it becomes 2xh plus h squared. Again, if you don't feel comfortable doing that, go ahead and FOIL those two out by multiplying x plus h times x plus h. And then this negative 5 is distributed, so that becomes negative 5x minus 5h. And then we have the plus 8. Then this negative 1 is also distributed, so that becomes negative x squared plus 5x minus 8 divided by h. All right? So I mentioned earlier, what if there was x to the 10th power? Wow, that's going to take you a long time to multiply that out. Okay? So now we can start eliminating our terms. The x squares are going to go away. The 5x are going to go away. The 8s are going to go away. Okay? So, and hopefully the terms that you have will only have the h's because again, we have to get rid of the h in the denominator. So this becomes 2xh plus h squared minus 5x divided by h. Okay. And then we're going to factor out the h. Then we've got backtrack again here. That should have been a h, not a 5x over h. Okay, so now I have h times 2x plus h minus 5 divided by h. Okay, and then this h will cancel, and this is what you would enter in the lab. Okay. Okay, so for this next example, we have f of x is equal to 1 over 2x. So again, we need to find the other component. So f of x plus h. So anytime I see an x, I'm going to replace it by x plus h. Okay. Then we're going to use a difference quotient, f of x plus h minus f of x all over h. And then we're going to replace these two terms here by what we just obtained. So we have 1 over 2x plus h minus 1 over 2x divided by h. Okay. Now, what I like to do in these types of problems is I like to solve them by parts to organize my information. So I'm going to focus on the numerator here first. Okay. So I'm going to write my scratch work on the side. So I have 1 over 2 times x plus h minus 1 over 2x. Okay? So remember, just like as we're subtracting fractions, we need a common denominator in order to subtract them. Okay? So, for example, if we have 1/2 minus 1/3, our LCD is 6, right? Because 2 times 3 is 6. So I need to multiply this by 3 over 3 and multiply this by 2 over 2. So that gives us 3 over 6 minus 2 over 6, which is 1/6. So again, in order for us to subtract or add fractions, we have to have the same common denominator. So that's what we're going to do here. So I have 2 times x plus h, and I have 2x. So that means then I need to, I'm gonna move this here. Okay. That means then I need to multiply these by factors so that we'll have the same common denominator. So our LCD in this case is 2x and then x plus h. Okay, that's going to be our LCD because we have the 2x here and we need the x plus h. We already have a 2, all right, so we don't have to say that again. So those are the three parts we need, okay? So 2x, 2, the x, and the x plus h, all right? So then that means that I need to multiply this by just x, right? This one here, because I need 2x in the denominator. So x over x, and then this one here, I need to multiply by x plus h. Okay. All right. So that gives us x over 2x times x plus h minus um, x plus h. I'm going to put that in parentheses divided by 2x times x plus h. Okay, so I have a negative here, and I put this in parentheses to let me to remember that I need to distribute that negative to each of my terms. So I'm going to have, again, x, I'll just write it out for right now, x minus x plus h divided by our denominator, 2x times x plus h. Now, sometimes I see this and don't do this, so students will say, oh, I have x plus h, I have an x plus h, I'll cancel that. Oh, I have an x, I'll cancel that with this x. Don't do that, okay? That's not correct, all right? So what I need to do is I have that -1 and I need to distribute that. So I'll have x minus h all over 2x and then x plus h. Okay. So then in this case, my x's go away and then I'm left with -h over 2x times x plus h. Okay. All right, but I'm not done because again, this is just the numerator. That's just the numerator. So now we need to plug this information for the top. Okay, so that's going to give us, no, we'll use a different color here. -h over 2x times x plus h divided by h. Okay. All right. So again, I know these problems are tough because it really tests your algebra skills, your simplifying skills. So, but if you get through this, it's probably the hardest problems we'll ever do in this class, because they're so involved. Okay. So, but if you get through this and you understand it, then the rest of the class is going to be not as difficult. Okay. So anyway, so let's go ahead and take this information here and move that there. And I'll delete that. All right, so this is what we have. Okay. So remember h, okay, dividing by h down here is the same thing as h over 1. So I can write this as h over 1. then I can just rewrite this as negative h over 2x times x plus h divided by, or sorry, times by 1 over h, right? So if I had 2 over 3 divided by 5, right? I can rewrite 5 as over 1, and then I keep the 2/3, and then my division becomes a multiplication, and then I flip the 5/1 to 1/5. That's exactly what I did there. Okay. All right. Same process. So that's what I tell students is that if you get stuck, go back to what you know. How would I do this in if it was just a simplified fraction form? How do I do that? How do I rewrite it? Okay. And that's what I do. Okay, so now we can start simplifying this. And so the h's are going to go away. Then we have negative 1, don't forget that negative there, over 2x and x plus h, right? And again, there is your answer there. I know it looks complicated, all right? But again, the information that we're missing here is that h goes to 0, and then if they give us a value for x, then we can find the slope of this function. Okay, so in this case, I have f of x is equal to the square root of x minus 1. So we need f of x plus h. So anytime I see an x, I'm going to replace it with x plus h. So this is going to give us x plus h minus 1. Okay, so these are the two types of information that I need to plug into my difference quotient. Okay, so f of x plus h is going to be this here. And then f of x is the square root of x minus 1 divided by h. Okay. Okay, so in this case, our goal here is to get rid of the radical. And there's a couple ways to do that. One is if we were solving an equation, we can square both sides and we can get rid of the radical that way. But in this case, we're not solving for a particular variable. We're simplifying, so we can't just square this, right? We can't just do that because it's not going to be the same thing. The right side does not equal the left side. All right. And then don't dare to do this because, again, that is not correct. Okay. So, so another way to do it is, as I mentioned, if you have 2 over radical 5, I can multiply the top and bottom by radical 5, and that will get rid of the radical in the denominator. And I can do the same thing if I had a radical on the top. I can multiply the top and bottom by the same radical because it's like multiplying by 1 because radical 2 divided by radical 2 is 1. So I haven't changed anything. Okay. So that gives me 2 over 5 radical 2, right? 2 over radical 5 is the same thing as 2 radical 5 over 5, and radical 2 over 5 is the same thing as 2 over 5 radical 2. All right. So they're equal. And anyway, this is called rationalizing the denominator for the top and then rationalizing the numerator for uh, the top. I'm sorry, rationalizing the denominator for the top part here and then rationalizing the numerator for the bottom part. But in this case, we're going to do something similar and instead of calling it rationalizing, we're calling it multiplying by the conjugate. So remember, if you have a squared minus b squared, that is, if you were to write the formula for this or factor that out, that'll be a minus b and then a plus b, right? So if we multiply this out, it gives you a squared minus b squared. So if you had x squared minus 9, that factored into x minus 3 and x plus 3. So if you had x minus 3, the conjugate would be x plus 3, and vice versa. If you had x plus 3, the conjugate would be x minus 3. Okay? So in this case, what we're going to be doing is we're going to multiply by the conjugate. So we have the square root of x plus h minus 1 by the square root of x minus 1. So that means then I'm going to multiply by the conjugate, which is the opposite of this. So that first term is going to stay the same. But instead of having a minus 1 in the middle, now we're going to have a positive. Okay? And then still have the square root of x minus 1 divided by, again, it's like multiplying by 1, so that means we got to do it again for the bottom. Because again, this whole thing here is equal to 1, so I'm basically multiplying by 1. All right, so notice that, again, we have, this is going to be my a minus b, and this is going to be my a plus b. Oops. Okay, so um, that's just the difference quotient, and that's why we're using this. That's why we're using this here, this formula. Now, again, if you don't feel comfortable doing that, again, you can multiply this whole thing together, which gets really complicated if you want to. Okay, I like to use a formula to make my life easier, so I'm going to use it. So in this case, then, um, I'm going to rewrite this as the square root of x plus h minus 1 square minus the square root of x minus 1 square. Okay, why can I do that? Because I just mentioned that these are being multiplied together, all right? And then when you apply the rule, you get this information. So the top part here is the right side of the information, and then what we got here on the second here line is this part of the information. Okay, so that's wonderful. And then we have that whole denominator still. And I'm going to represent this sucker here as D. Okay, so I'll have HD, so I don't have to keep writing that whole big thing. Okay, so okay, so let me erase this down here. All right, so now we have um, the radical and the square, so they're going to cancel. Okay, so this is cancel with that, and then the radical and the square goes away. So we have x plus h minus 1 minus, again, put this in parentheses, x minus 1, and I have hd. Again, that d represents this bottom portion of the denominator. So to kind of just simplify it, and I don't have to keep writing that whole thing out. Okay. All right, so now we just simplify. So we get x plus h minus 1 minus x plus 1 divided by hd. Again, I just have a negative one here, so I distribute that to each term. Okay, and then I can cancel some information. So the x's go away, then the ones go away. So then we're left with equals h over hd, and then the h's go away, leaving us with 1 over d. Okay, now we know what the lowercase d here is, and that was, we represented it by this term. So we're just going to replace that back, substitute that information back. So we have the square root of x plus h minus 1 plus the square root of x minus 1. And then that will be our answer there.